Today we're going to be discussing home networks and the issues that are involved therein, uh, how those networks manifest themselves at the customer's home, the security involved taking care of them, uh, the internet itself, LAN, and file sharing. PANs, LANs, and WANs. So PAN is a personal area network formed by connecting a lot of different devices together for the use of one person. Good examples of this are Bluetooth and infrared. Infrared technology can be used to control things like televisions and stereos, as though things like a telephone are a remote. Some telephones even have IR transmitters on them. The personal area network is extremely diverse. Kind of all depends on how the individual is looking to be connected. Phones can link to computers, can link to headsets, speakers, smart watches like the Apple Watch and smart gear, things like that. The LAN is the local area network. This takes and links computers together that are in a small area. Great examples of this are small business networks and home networks. The WAN is a wide area network, and this is a network that spans regions, countries, sometimes even the globe. The internet is essentially the wide area network. Global corporations also often use wide area networks to ensure that all the computing devices that the company owns can be on a secure network. So this is a great example of a home network. This is my home network. On the right here we've got the internet connected to a Motorola Surfboard modem connected to an Asus wireless router. The Asus wireless router is connected wired to an Xbox 360, a Samsung Blu-ray player, and an Xbox One. There are wireless connections between the Asus router and my personal gaming computer, an MSI GT70, a business computer which is a Dell 5570, and several smartphones which use the Wi-Fi to avoid incurring data charges. Home network security. The LifeWire 10 Tips for Wireless Network Safety article was a great introduction to wireless network security. I think anyone who's looked for a Wi-Fi network at their home and has seen Linksys routers, which use a very predictable naming convention. People never change the SSID. They never stopped broadcasting the SSID. I was actually broadcasting my SSID until I read this, and eventually, after reading it, I went ahead and logged in and stopped broadcasting. If the network doesn't appear, hackers will usually look for easier targets unless you're being targeted in specific. Overall basic security of my network is relatively good. LifeWire network security questions answered. had some great ideas for parents that are looking to keep their children off the internet or to regulate what their children are seeing on the internet and when they can use it. Made some important points about WPA and WPA2 versus WEP, which is no longer considered a very secure protocol. Good answers to common questions, and it was good to know that WPA and WPA2 was the way to go for my network, which is what I've been using. The PC World article was a good mix of basic and advanced instructions. I've been employing the basic instructions for a while. The advanced network instructions that they were, suggestions that they were giving, I would like to learn a little bit more about before I implement them. So I haven't implemented any of them yet. NMAP, Network Map, is one of the tools that was listed in our last article. Shows statistics of the network that, well, any given machine or machines that you specify on a network that you're on. I use this to map my personal computer. Overall security of our network here is relatively strong. All the basic points are covered, especially now that I stopped broadcasting our SSID. I'm going to be looking into more of the advanced features as time goes on and I understand a little bit more. So this is a screen cap of NMAP. Basically, I downloaded NMAP, and this is their GUI that is used to, the interface that's used to tell the program what to do. I went ahead and mapped the network traffic for just the computer that I'm creating this on, and the results are displayed in that screen capture there. File sharing. File sharing can be a lot of things. It's essentially what it sounds like, sharing files over any given network. There are 7 factors that will impact whether a person can share files and how much they can share. These are going to be which locations the machine can discover and whether the machine is discoverable, whether the user has permissions to access the files and whether others have permissions to access the files of the user, which files the user chooses to share and which files others choose to share with the user, and the types of permissions available. We'll go over those as well. This is a screen cap of my network at home. I don't have many devices to share files across. That's not my primary method of transferring files here at home. Part of the reason is security concerns, even though I have basic security in place for my network. There's no telling how advanced someone can get and possibly crack into that. To see what devices and drives are connected over the network, just visit the Network Center in the File Explorer in Windows, or Explorer or Finder in Mac OS. Usually by default the machine will have sharing turned off, so the computer will ask you if you want to turn sharing on, and in order to see other devices on the network you have to turn sharing on. Then you'll be able to see all of the other devices that are available to share over the network. As far as security goes, file sharing is a huge vulnerability. I would recommend only sharing files with trusted people, trusted users, trusted machines. Use the correct permissions when you're sharing files. If there is a user that should not have the permission to write or change, make sure that that person does not have the permission to write or change. And very important, only share files over trusted private networks with strong security. Like I said, that's part of the reason that I don't share much over my network. File sharing permissions, there are 3 different types. The permission to read, which is pretty self-explanatory, means that you can read the file. Permission to change, meaning that you can make changes to the file. And full permissions mean you can read and change the file. Connectivity protocols. So between wireless and Ethernet protocols, there are a lot of differences. We can see the speeds available at 54 megabits per second, which is 802.11g. So Wi-Fi G is only 54 Mbps. The Ethernet, gigabit Ethernet, is obviously 1,000 megabits per second. With Wi-Fi N protocol, you can get up to 600 megabits per second. Those are usually very high-end routers that are extremely expensive, so it's more common to see between 150 and 300 megabits per second on the wireless N protocol. The new wireless AC protocol boasts up to 1,000 megabits per second, so closing the gap quickly with respect to speed over Ethernet. Strength of Wi-Fi: user-friendliness, convenience, ease of connectivity. When someone walks into your home, they don't typically ask for an Ethernet jack, they ask for a Wi-Fi password. It just doesn't get more convenient. Ethernet, though, is secure, it's reliable, and for now it's got the edge speed-wise. It's very expensive to get that 1,000 megabits per second over wireless AC, even though it's available. Weaknesses of Wi-Fi: the cost of high speed. The AC routers are extremely expensive still. It's a new technology. Security weaknesses: no one necessarily has to be in your house to hack a wireless network. And signal interference: there are a lot of things, household items, that will interfere with wireless connectivity. Things like refrigerators and microwaves often interfere with that signal. Ethernet, though, is bulky and cumbersome for large applications. The cost can be high. There's a lot of wire that goes into it, a lot of planning that goes into the infrastructure of building a wired network, and it's slowly losing the edge that it had on speed. As far as range goes for Wi-Fi, maximum range is going to be 32 meters without a range extender, and for Ethernet, maximum range is going to be 100 meters with Cat 6A. So domains, top-level domains are the big domains, the ones that you will expect to host multiple services. .com, .org, .mil, .edu, .gov. .co is the domain for Colombia. Countries have their own domains, large companies have their own domains, things like that. The DNS, Domain Name Service, resolves domain names into the underlying IP address. So Google.com is not an actual IP address. The DNS takes www.google.com and resolves that for the client computer. DNS was invented toward the beginning of the internet boom, so it was extremely adaptable. It still is extremely adaptable. It's scalable. It's innovative. Unfortunately, it's got some security vulnerabilities that are becoming very apparent. Hackers regularly use DNS to create botnets. The botnets are used to propagate DDoS attacks on internet service providers. There have been a few examples of this recently, and most recently these have been used to attack the Internet of Things, which has a fairly low security rating right now. Will need to be worked on in the very near future. Governing and funding the internet. No single company, person, or government actually runs the internet. It's run by various concerned parties, including people from government, people from private businesses, academia, from all over the world and all over the spectrum, things get done in a very decentralized manner. Some companies, like ICANN, which is the Internet Naming Commission, have more direct control over things like naming because it's a necessity. However, because of the fact that the internet isn't governed through any centralized company or commission, the same people that govern in the decentralized manner are the people who stand to make money off of the changes in policy. So it's led to some concerns about conflict of interest. Data transmission. Start with packets. A packet is a segment of data that contains a bunch of different identifiers, and then the data itself that the user is looking to send also contains a source and a destination, and usually a position where that packet fits into the entirety of the data when it arrives where it needs to be. A packet switching network. Data is arranged into packets that have data in them that explain what order the packets go in when they arrive at their destination. The data is duplicated so that if packets are lost during the transmission, there's less likelihood that the receiving computer will need to request a resend, which would cause delay in time. TCP/IP protocols are the protocols that are used to reconstruct that data after it has arrived at the destination, and the protocols that are used to construct the data going out, to construct the packets by the computer that's sending them. UDP, User Datagram Protocol, is a part of the Internet Protocol Suite. So static and dynamic addresses. A static address is an IP address that does not change. It's usually given to you by your ISP and will remain the same. These are usually assigned to large servers that are hosting multiple services. As I said, Google.com is a static IP address. That IP address does not change, otherwise users wouldn't have any way to find it. Dynamic addresses usually are assigned to clients, individual users, and they're usually assigned when the machine boots. The machine contacts a DHCP server, which then assigns it an IP address so that it can access the greater internet.